Well, hello and welcome back to the radio room. We're back to looking at the HW 101. You can see the top of it there. Um, Now, this is a little bit of an update video. It's an update video, but it's it's an interesting one. Continued working on the 101 here. You can probably maybe tell. I do got the two O-rings, rubber bands, whatever you want to call them. These are some other ones that I got in that are just a little bit smaller than the silicone ones that were I pointed out in the last video. I think it was the last video. They do work just fine in turning the very old capacitors just like they're supposed to. So that's not a problem. Um, Did a little other work. Did change the microphone connector out. Oh, and I did find some bulbs. You can't see them in the camera. Let me see if I can move this over here. Did find some new bulbs. I actually had some. I ordered some number 44s, but I had some number 47s. Both 6.3 volt. These are actually just a little bit lower wattage and take a little bit less amperage, and they're plenty bright. So, and I would love to turn the radio on and show them to you. However, I can't right now. I got that done, got the light bulbs changed, got the bands changed, the belts changed, whatever you want to call them, changed, and decided I was going to do an alignment on the radio. Went through the alignment. The alignment was fairly straightforward. The 29 megahertz band is not working. I could not get the appropriate voltages even when I was adjusting the heterodyne oscillator slug. I'm thinking it's maybe the crystal is bad. I've checked some other things on it in the band switching. Everything seems good. I think it might be the crystal, so I might have to find another crystal. The hard part is that does make doing the alignment a little difficult, because you have to go, when you're doing part of the alignment, you have to tune in very specific order. And 29 is not the last one you do. So the previous steps can affect the next steps. And when you can't tune 29 correctly, it could have effect on the next bands in the order of doing the alignment. But I pressed forward. I went ahead and did the alignment. Hope for the best. Went past 29 and did the alignments. I was getting fairly decent power outputs. I went all the way through the transmitter alignment. In fact, this one doesn't look like it's going to need the... according to the way that the manual says, it shouldn't need an alignment. Just from the fact of where I was looking at going through the process, and there's a check that you can do to see if it needs an alignment, and it passed that test just fine. So I went basically completely through the alignment. I realigned the VCO. I realigned the VCO, let's call it band spread, so that the dial lines up pretty close. I still needed to do the calibrator alignment, but hadn't quite gotten that far. I was going through all the transmitter stuff, doing pretty much the last step, resetting the heterodyne oscillator for maximum output on transmit, and I was getting on 80, 40, 20, I think even 21 megahertz. I was getting roughly around 100 watts. And before that, I was getting up to, say, 60, 70 out on the 10 meter bands, which could be affected because of the fact I couldn't get 29 megahertz lined up. It could be affecting those other ones. Anyhow, things went awry. Things went awry very badly, very quickly while I was making those adjustments. Let's just say there was lights, there was arcing, there was sparks, there was smoke, and there was me finding the on-off switch and trying to disconnect the power cable at the same time and get back from thing. It was a pretty light show. So let me go ahead and move to a different view here. I could not get the light on this very good. I got some camera pictures that I'll show you, but you can probably tell in that picture something don't look quite right. In fact, in a couple of places, like right here, that's not supposed to look like that. And I got some better pictures here in a minute. And then over here, don't look right either. This is where most of my light show was coming from, right here. And I'll move over to some pictures here, and we'll kind of discuss what was going on. Let's just say I could have lit up the workbench without the lights on, as those two resistors were doing their thing. So let me see if I can get over to here. This is a little bit closer to the left one, the first one I showed you. That used to be a resistor. Sorry about the focus. I was trying to get in close and take a look at get things taken care of as far as doing. No, that's actually the right one right there. I'm sorry. That would have been the one that was on the right. That's that first picture is this one over here, right there. So it's pretty toasty. And then let me go over to our next picture here. This is the left one. It's totally obliterated. You can see all the scorching marks on this shield right here. Of course, over here is the first one I was showing you, and lots of soot and everything on that shield as well. And then it continues. So right here is a choke. You can see this burning right here. So I have a feeling this choke is probably done for. That's actually connected to this resistor here on the other side of this board right here. So this is a fairly simple fix. I mean, it's just a resistor. The one over here is just a resistor. This I'm probably going to have to find if it's damaged. And you can see it had enough arcing that this is, here's that choke right here. Never mind this cobweb. Somehow that one got past me. Little scratch mark right here. I was putting a tool in there to see what this might have been. I think that's just some old flux. I was thinking maybe it was something that was damaged, but that little spot right there is just where I kind of scraped some of this burn off of here. So yeah, not so good. But I think I know what caused the problem. These boards here, this one, and then there's another one off over here. These have the, let me see if I actually made it into a picture. You can't really see them. Try one more. No, you can't really see them. I didn't get them in the picture, but this is where all the tuning coils are along these boards for tuning the driver grid, the driver plate, and the heterodyne oscillator. So what I think happened was, and let me see if you guys can kind of see. Okay, so right there is some of those tuning coils. This was an issue that was looking for a moment to happen for almost 47 years. This radio, I'm going to guess, was probably put together from its kit in late 1977. early 1978. I did find the purchase receipt that was in with the manual, where it was purchased in September of 1977, late 1977. So in this picture is what I'm pretty sure is the problem. I think I have one more picture of it, might show it a little bit better. So right here, I'm pretty sure is what the problem was. This wire right here, it's got this little bare tip on it. I believe made contact with this right here. Well, that's not good. And that's actually just a touch further away from that in that picture than it was. I didn't catch this when I was going through the radio to begin with, but that thing was sitting right next to that for 47 years. And I'm pretty sure that's what took it out, and I'll explain why here in just a minute. The funny part of this is that there's an alignment adjustment that involves that wire, which I determined I didn't need to do because of certain tests that are performed when you're doing the alignment. If it passes the test, you don't do that alignment. I'll discuss that here in just a moment. But let me go to, let's go to the schematic and see if and I can show you kind of what the problem was here. So that choke, let me find it. That choke that I am suspecting might be blown up, and I'll have to unsolder it and see if I can get it out of there and check it out. It does test still having continuity, but that doesn't mean all the windings aren't shorted together. So that's right here. Right there is that choke. And that resistor that was to the left in the first, when I was showing the live picture of the beside the radio that y'all probably couldn't see worth a darn. This is the resistor. And you'll notice there's 300 volts on here. Where the other deal comes in, that white wire made contact somewhere in this area. This is just the schematic, so this isn't literal. You're not going to see that white wire on here because it's not part of this circuit right here. Basically, it made contact with this side of the coil. Where it solders through, this is through a hole, and then the solder trace actually kind of winds around a little bit on the board where a lot of these other connections are made. Well, if we go over here, see if I can find this again. There's this right here. It says neutralization wire. That wire is, as you can see, connected to, it's basically those variable caps. So this, well, actually, right here. This is a little bit different than the way it's physically hooked up. It's a good electrical representation of it. So this wire basically is running down beside in that board to put a little feedback from the plate tank circuit, which is right here. This is the plate of the driver right there. See how this is coming over here? So this is basically running next to, let's call it this side of this circuit. But it comes off of one of them variable capacitors. And it just sits next to it. It's loosely capacitively coupled in order so that it can give some feedback from the tank circuit back to the plate to provide a little feedback so that it can neutralize and keep that driver from self-oscillating. And I'll just I'll kind of show you a little bit what I'm talking about as far as it sits down in there. So hold on a second, I gotta get my computer to want to play the same game I'm playing. It's not want to. Give me just a second. Oh, okay. It's not. The computer's not playing. It's not playing games with me, right? Let me just do this. So, the other end of that wire that we were looking at in that picture is this wire right here. Get my fingers out of the way. It's that white wire running right there. It just sticks down through the board. And by doing that and running up against that circuit board, and where it's running through that circuit board, it capacitively couples and gives feedback basically to the driver tube. Well, it's connected to this. It basically just runs up here to the back right here, goes to this. Now this isn't straight to ground. It's floating above ground. But let's see if I can get this thing to cooperate with me this time. Right here's our wire. And right here is another 100 ohm resistor that's going to ground. That's the other resistor that is cooked. So basically when that white wire touched here, it got 300 volts on it, which took it to ground through this 100 watt or 100 ohm resistor. Well, that didn't last very long. That's only a half watt resistor. You got 300 volts basically straight to it. So in total, there's 200 ohms of resistance that was between the 300 volt V plus and ground. Both half watt resistors. You can do the math on that, but what is it? 1.5 amps? Okay. So 1.5 amps times 300 volts. That's a little more than a half a watt. Quite a bit more than a half a watt. So basically what happened is once it made contact, and what happened was while I was doing a adjustment, something in there flexed and made that wire, which was, you probably could have barely put a piece of paper between the tip of that bare wire and where 300 volts was sitting. Maybe a business card. And it flexed just enough to arc over or touch it. And then once it did that, it probably temporarily tacked it there for just long enough that the 200 ohm resistors and that coil said, nope, we're not doing it. So that's where all the arcing and the bad magic smoke came from. And I'm here to tell you the radiator ohm still smells. So that's pretty much where I'm at. I can't even figure out to really diagnose the 29 megahertz band right now until I get this fixed. So what I'm going to do is I'm going to change those resistors, and I'm also going to move them away from the let me see if I can get this to do this or not. Okay, so I got my pictures back. So like I said, that's just so darn close. This is actually going to get some probably some heat shrink put around it. Moving this wire away from it or up and down will change the neutralization. I mean, the adjustment, and this is why I'm saying I'm glad I didn't have to do this adjustment. Of course, I guess it didn't make any difference in the long run. But if I'd done that adjustment, I might have either completely saved the problem from happening by maybe moving that further away, or B, would have made contact with it that time and still have the same problem. And I'm not sure I would have wanted to do that while I got my finger next to that wire sitting right next to a hot tube. Not to mention probably a hand sitting on part of the chassis and that one part of that basically housing of that capacitor, variable capacitor, getting 300 volts put to it might have stung a little bit. But that'll get some heat shrink around it. I mean, that's when the radio was built. That's what it was. Like I said, it was actually just a little bit closer. I'm pretty sure that if the guy who built the radio had known that, he wouldn't have done that. This actually, it looks burnt right there. It's not. That's more of a shadow than anything from this wire with the light coming down. But I have a feeling that he stripped the wire, thinking it was going to connect to something, and then went, "Oh no, it doesn't." Well, he didn't think about that sticking out there right next to 300 volts, or he probably would have put some heat shrink over it or not stripped it down. Another thing is these are extremely close to that grounded shield. They were probably almost just about touching it, if not touching it, which isn't necessarily a problem when it's not burning itself to pieces. That had some arcing as well. So that 300 volts, you'll notice this one's slightly less cooked. I mean, it blew the outer coating clean off of this thing. This one's more charred with some flakes off. But what happened, I believe, was when the wire touched, which is right down in here, when the wire touched, of course the 300 volts went through the coil, back out through the top variable capacitor, which is right here. You can see the bottom of it right there, the legs coming through. Went through here and cooked this one. When this one failed, I have a feeling this one had already overheated enough that it had started arcing to here. And, plasma conducts electricity, and that's what arcing is. I think once it started arcing right there, it just kept arcing. And that's where the real show came from, because it was gapping this right here. And it was like a welder. So, yeah, got some problems on the HW101. But we're going to get them figured out. I think the hardest part about fixing this is if I have to replace the choke, this right here, is maybe getting one. I need to find one that'll fit right there. It's a 15 microhenry RF choke. As long as I can find one, it might be a little fun getting to the bottom solder joint. That leg you can see right there is going to be no problem to unsolder. But the bottom one's in there a little bit further, but I think I just got to be careful getting the soldering iron in there, because I am not disassembling the band switches. It's not happening. That is a lot to undo, and you're praying that 47 years of age isn't going to make it so something just falls apart. So I'll see if I can get these parts out of here, see what I need to do to get them replaced. Fortunately, I mean, for cooking components and magic smoke coming out and a heck of a light show, it was a pretty direct short. I mean, minus the 200 ohms that was in between the B plus and ground. It was a short circuit. It didn't have to passed through a lot of circuits in the radio when it went. It was basically from that red wire that you see in the picture, through that resistor, through the coil, basically right to that white wire, back up, and in that other resistor. That's really the only thing that was in the circuit. I will take a look at the power supply real quick and check the 300 volts on it. Just make sure that it didn't do anything to the power supply. I hope not. Really, if it did anything, it didn't pop the breaker on the power supply, which either means A, the power supply breaker isn't very trustworthy, but I'm hoping it didn't take out any components on the power supply. Most of those are replaceable as long as it didn't damage the transformer. We should be good. But I just thought I'd give you all an update and kind of let y'all know it was a very successful day that ended very spicy. Just about had everything aligned. Was going to try and figure out that 29 megahertz band. And really, to tell you the truth, I was hoping to have this video being, hey, you know, this thing's got some life in it. We can actually do some transmitting. Even maybe get down on some of the lower bands and make a contact or two just to verify that it's got output. But can't turn anything on till I get this fixed, or we have no B plus on the, let's see, the modulator. Well, might have some on the modulator board. But I think the first and second transmitter mixers and the driver tube, no B plus on them right now because they all go through that choke. So that's the update. It's not a great one, but we're going to press on. I'll figure something out on that choke. There's got to be something out there to use, even if it's not the exact same part that Heathkit put in there. Maybe I can find something better. Oh, important note. While I was doing the alignment, and if anybody is kind of looking at this video because they've been maybe working on an HW101 and they've seen a lot of the other alignments, by the way, Will Everett has a wonderful video on doing the alignment on this as well. After I'd done the alignment, I'm working on an HW101. I was sitting back, fuming, scratching my head, looking at the schematic, trying to figure out what in the heck went wrong. So I was just watching some YouTube at the same time, and I'm working on a 101. I watch 101 videos. Maybe I can pick up something here and there. And he's actually got a nice one, nice video on doing the alignment. But if you look at some of those alignment videos, when you get to the the carrier suppression, is what I call it, the carrier null. You have a carrier null potentiometer. In every video that I've seen, and even some of the literature that I've read online, the carrier null potentiometer is notorious for failing after so many years. So a lot of times you see them, they're doing the alignment, they get to the carrier null, they turn it on that, it just won't null the carrier on sideband. So they have to change it. And I was really kind of apprehensive when I got to that part of the alignment because I don't have a replacement potentiometer to put in there. I mean, I can order one. But then I got to wait. Of course, I got to wait now if I got to get a choke. I went in there. I was using an oscilloscope to check it, not a receiver or an RF probe or anything like that. Using the oscilloscope, watching the oscilloscope, started turning that potentiometer, and it nulled the carrier. Went over to upper sideband, and just about had it matched between the two. Did a little tweak on the capacitor, which is pretty much set right where it needed to be. But I was able to null the carrier with the original potentiometer. In the future, I may change it out just because this one's probably likely to fail at some point. It seems like a weak point from what I've noticed on the HW 101s from everything that I've read, seen, watched, heard. But mine was still working, and I'm glad of that. 47 years. and it just nulled it right down. Didn't actually even take a whole lot of adjustment. So I'm glad I got through most of the alignment. There's a few problems to work out. One really big one, because I can't even turn the radio on now without probably watching another light show. That resistor right there might start arcing again. It's still going to have 300 volts on it coming from that red wire, whether it's blown up or not. So hopefully next video we'll have this replaced, these components replaced, and we'll maybe discuss the 29 megahertz band, see if I can figure this out, something on that. I might have to get another crystal. I'm sure I can find one out there. And I'll probably do some other diagnostics, mostly some continuity checks, because I can't turn anything on right now. But thanks for stopping by. And, you know, never is fun when the spicy electrons go places they're not supposed to be, because they let the magic smoke out. So watch out for the spicy electrons and make sure they don't go through you. We'll see you next time.